All right, Calc kids, I'm going to go through your practice test really quickly. So, what should you expect for your test on Tuesday? Well, here are the sections that we covered. So, 3.7 is the chain rule, 3.8 is inverses and trig inverses, 3.9 was exponential functions and logs, and 3.10 is implicit differentiation. So we've been working on that for the past couple weeks. Hopefully you guys know what's going on. So I'm just going to start here. If you have any questions, we can go over them on Monday, and hopefully this video helps you out in some way. So first up, explain how to use the chain rule in your own words. So the way I would explain it is we have a function inside a function. So if I take the derivative of that, that means I'm going to take the derivative of u times whatever the derivative of the inside is. So another way of saying that is the derivative of the big function times the derivative of the inside. And that's how we've been going about this. If you take the derivative of a function, it's the derivative of the big function times whatever's inside. So that's, you might use different words to explain it, but expect to be asked how to explain something on your test. Next up, the derivatives of inverse functions. So these are just memorization. So I go, derivative of inverse sine is 1 over square root 1 minus x squared. The derivative of cosine, anything with a co should have a negative in it. So that's negative 1 over square root 1 minus x squared. Derivative of inverse tangent is 1 over x squared plus 1. The derivative of cotangent inverse is negative 1 over x squared plus 1. Secant sucks, so it's 1 over absolute value of x times the square root of x squared minus 1. And negative cosecant, inverse cosecant is negative 1 over absolute value of x, square root x squared minus 1, because cosecant sucks. I expect you guys to know these, be able to implement them any which way. Next up, derivatives of exponential and log functions. If you have a different base than e to the x, the derivative is ln, for this case 10, times 10 to the x. Log base 10 times itself. The derivative of ln of x, that's the one that we've been using the most the past couple days, it's 1 over x. So now that we got all of these written out, let's just work out on some derivatives on our own. So looking at problem 4, we've got 6 different derivatives, each using the chain rule. So let's just get to work. So first one, I have 4t minus 3 to the negative 8th power. So treat this as something to the negative 8th power. Let's make that a little bigger. So that's negative 8 times whatever's on the inside. Drop it down 1, so to the negative 9th, times the derivative on what's on the inside. So 4t minus 3, the derivative is 4. So our answer is negative 32, 4t minus 3 to the negative 9th. Since the problem was given to us as a negative exponent, you can leave it as a negative exponent. Let's move to b. First, let's rewrite this so it's exponents. So I have 2z minus 1 to the 1/3 power. So take the derivative. G prime is, that's y prime up there. G prime is going to be 1/3 whatever's on the inside. So that's 2z minus 1 minus 1. So that's negative 2/3 times the derivative of the inside. Derivative of 2z minus 1 is 2. So if I wanted to simplify this one, I can either write it as 2/3 times this, or I'm going to say it's 2 over 3 2z minus 1 to the 2/3. And let's leave our answer just like that. Next up, the derivative for c, we have f prime equals the derivative of theta is 1 plus the derivative of tangent is secant squared. So I have 2 secant squared of what's on the inside. So that's the cubed root of theta times the derivative of the cubed root of theta. So if we have, let's just write that as theta to the 1/3. So that means the derivative of theta to the 1/3 is 1/3 theta to the negative 2/3. So I'm left with 1 plus 2/3 secant squared cube root of theta times theta to the negative 2/3 power. If I don't want that negative exponent, I'm going to write that as 1 plus 2 secant squared cubed root of theta all over, bring this down, so that's 3 theta to the 2/3 power. Let's keep that on screen. So I have 1 plus this giant quantity. There's my answer. That's what f prime of theta is. Moving on. Let's look at D, E, and F. I have the derivative of 1 over something. So this is a quotient rule. So I have 1, my high function is 1, so D high is 0. That makes it a little easier. My ho function is 4 sine x minus 3. So my D ho function is, well, the derivative of sine is cosine. So I have 4 cosine x minus 3 times the derivative of what's on the inside, which is 1. So there's our D ho. So we go quotient rule. We go ho D high, 4 times 0. Okay, that's easy. Minus high D ho. So that's 4 cosine x minus 3 all over 4 sine x minus 3 squared. And if you didn't want to write the 0, it would just be negative 4 cosine x minus 3 divided by 4 sine x minus 3 squared. Next up, the derivative of sine inverse of 7x. So if we look back up at the top, we already wrote down what the derivative inverse sine x is. So we say, what's the derivative? So y prime equals 1 over the square root 1 minus 7x squared times, what's the derivative of the inside? 7x, so it's 7. So my answer is 7 over the square root of 1 minus 49x squared. There's our answer. Last bit, we have f, this whole mess. We see that's a quotient rule, so I'm just going to write it out. My high function is ln 2x plus 6. So d high is 1 over 2x plus 6 times 2. And my ho function is x squared minus 5x plus x to the negative third. D ho, that's just power rule on each one. So that's 2x minus 5 minus 3x to the negative fourth. So if I write out my quotient rule, it's as simple as ho d high. So I have ho d high x squared minus 5x plus x to the negative third d high times 2 over 2x plus 6 minus high d ho ln 2x plus 6 times 2x minus 5 minus 3x to the negative fourth. Let's see if that fits. All over ho x squared minus 5x plus x to the negative third squared. If we look at all of that, I'm not going to ask you to simplify that. Once you get to here, leave it. Let's move on to the second page. Moving on to the second page, this problem, if we look at number 5, it says, assume f and g are inverses of each other. Remember, with inverses, if we said g prime of something is the reciprocal of f prime of something when f is equal to a value. So we want to know what g prime, when is g prime of 1 here? Well, it's when f is equal to 1. We're assuming these are inverses, so what's the reciprocal of 4/3? G prime of 1 is 4/3. That problem's super easy. So let's look at problem number 6. Let's just make it a little brighter for you guys. How do we set up these inverse problems? We're asking, we want to know g prime of 1. That's the reciprocal of f prime of something when f of something equals 1. We take this input, and that's when we set our function equal to that. So we have our function. We're not asked to find the inverse. So we want to know when f is equal to 1. So I want to set our function equal to 1. Now, we could multiply, solve this, or we can simply investigate 1 divided by some number is equal to 1. So what makes this denominator 1? The only time that could be is when x equals 0. So f of 0 equals 1. So now I want to take the derivative and plug in 0. So what is the derivative of f prime? Well, we have a quotient rule, or another way of writing this is 1 plus x cubed to the negative 1/2 power. That's a lot easier to work with. So f prime is, bring the negative 1/2 down, times, subtract, so that's negative 3/2. What's the derivative of the inside? Times 3x squared. So I'm left with f prime equals negative 3, sorry, I should write this, 1 plus x cubed, negative 3x squared over 2 square root, right? That's a negative. Let's just leave it as, let's rewrite this. This is negative 3x squared over 2, 1 plus x cubed to the 3 halves. Okay, that's a lot easier. I want to know when is f prime, what's f prime of 0? So that gives me negative 3, 0 squared, this is easy, times 2, 1 to the 3 halves. So that gives me 1, that gives me 2, this gives me 0. F prime of 0 is 0. So g prime of 1, what's the reciprocal of 0? 0. We take the reciprocal of this to get our answer. I know it's a lot of steps, but as long as you can get this set up, set your function equal to this value, find when that's 0. Okay, so in this case it was 0. Now I take the derivative and plug that number in. Take the reciprocal. Last couple problems. Use implicit differentiation. When we're doing this is just like a chain rule. So we want the derivative with respect to x for both sides, d dx. So I want to say, what's the derivative of this something? Well, it's 4y cubed times its derivative, dy dx. What's the derivative of negative 2y? Well, it's negative 2, bring down the 1, so that y goes away, times y's derivative, dy dx, equals, well, derivative 4x cubed, 12x squared, derivative x, 1. Now, we want to solve for dy dx. So I can factor a dy dx out of both of these. So dy dx, what's left on the inside? 4y cubed minus 2 equals 12x squared plus 1. Last up, divide both sides by 4y cubed minus 2. So I have dy dx equals 12x squared plus 1 all over 4y cubed minus 2. There you have it. Implicit differentiation. Next up, I want to do the same thing. Take the derivative d dx of both sides. So the derivative of ln of x, 1 over x, plus the derivative of ln of y is 1 over y times dy dx equals derivative of x, 1, the derivative of negative y, negative 1 dy dx. Now I'm just going to get all of the y's, the dy dx's on the same side. So I have 1 over y dy dx plus dy dx equals 1 minus 1 over x. Factor out the dy dx, dy dx, 1 over y plus 1 equals 1 minus 1 over x. So divide both sides, we get 1 over, I have dy dx equals 1 minus 1 over x divided by 1 over y plus 1. We can leave this. We can also do more algebra. We're going to have to clear the top and bottom. So we're going to have to multiply both the top and bottom by xy. So that leaves you with, if we wanted to do a little extra credit, we have xy minus y divided by x plus xy. These two are equivalent. This one has fractions, this one doesn't. I like these ones the best. Last problem of this entire practice test. We want the derivative of y equals sine of x plus y. So I say dy dx, that's the derivative of y, equals, the derivative of sine is cosine x plus y times the derivative of the inside, which is 1 plus dy dx. So that means I have to do a little more work. I have dx equals cosine x plus y plus cosine x plus y dy dx. I'm going to subtract this. So I have dy dx minus cosine x plus y dy dx equals cosine x plus y. Almost there. Factor out the dy dx. So I have dy dx 1 minus cosine x plus y equals cosine x plus y. Last bit, divide both sides, so I have dy dx equals cosine x plus y over 1 minus cosine x plus y. There you go. We'll go over any and all of these questions, plus logarithmic differentiation, which we worked out on Friday, and Thursday will be on the test. You guys are going to do fine. Just know your stuff. All right, good luck. Bye.